Okay. Good morning. The only thing that stands between you and lunch is me. Lock the doors. Yeah, here we go. So nice to see so many familiar faces. I wonder if there's anyone I don't know here. So we're going to have a little discussion. This is a little divergence for normal interoperability. Sorry. Technical hitch. That's better, is it? Okay, so a little step away from normal interoperability discussions. I'm just going to talk a little bit about OpenStack and the continuous integration lab that we've been running since January, I think is a fair. So this is really what I'm going to talk about. Just a little bit. I want to give a little history of OpenStack in Windows. That's what you might call a roller coaster ride to some degree. I'll talk a little bit about the Windows, Microsoft, however you want to dress it up, Windows contribution to the OpenStack ecosystem. Then I'll talk a little about the continuous integration lab. We have one currently in Cambridge, Massachusetts, and we're busy building one here in Redmond. And then I'll just talk about some of the challenges and things. And the good news is today, if you've got technical questions, all my guys are here, so I don't need to answer them. They can answer them. That makes life. You can't heckle me now. I can just hand it off. Sorry, deal with the heckle, would you? So this is probably a bit of an eye chart if you're at the back of the room. But this is the kind of history, very potted history of what we've done in the OpenStack. So back in about October 2010, we hired a vendor to write some code to make Hyper-V part of OpenStack. And then in the best tradition, we forgot about everything. And we got ejected. Clearly we were on the ball. Oh, maybe we weren't. But then much more recently, June 2012, we went and found another vendor company to help us out. This time cloud-based solutions, and they've been a fantastic partner for us. And they did a bunch of work, and we got Hyper-V back into OpenStack. For those that know anything about, or those that don't know anything about OpenStack, even fulsome, OpenStack releases are like hurricanes. They get named with a letter. So I don't know if it was deliberate to name them like hurricanes. Maybe that was wishful thinking, or I don't know. Oh, prisons. Are prisons named in America named after in alphabetical order? Is Folsom a prison? See, I don't. Yeah. See, where I come from, Barrel is the prison, and that's in the middle of Glasgow. So I don't know anything about American prisons, fortunately. Well, none that I will admit to. I'm getting educated here. Where do we get to? I'm distracted. June. We get asked back, to say in June last year, saying we need you guys to set up a CI lab. If you want to keep Hyper-V code as part of OpenStack, you have to set up a continuous integration lab. The problem with that ask of a company like Microsoft is that's like in the middle of the financial year. You know, our budgets are done and locked. So now we have to kind of build a system with no budget. And actually getting a budget is kind of hard mid-year. So actually, now, that's the bad thing about working for Microsoft. The good thing about working for Microsoft is if you need to build a lab with a couple of hundred servers, if you go scavenging in Microsoft, you can actually find a couple of hundred unused servers, which is kind of handy, really. And that's exactly what my guys did. We did a lot of scavenging and scrounging and begging and borrowing and other things that lead you to Folsom. And anyway, so we literally built our lab based on begged and borrowed hardware. In fact, I'm not sure we actually budgeted a single dollar to build the lab first time round. We didn't. It was literally begged, borrowed.
And stole.
I didn't say that, he said that. Notice that. And then, as I say, we managed to get the lab together, and I tell you what, I would like to claim I put lots of effort in. I really did very little. There's lots of guys sitting around here. I actually did a lot of blood, sweat, and tears to get this lab up and running. Come February, we got reclassified as a Group B hypervisor, which means we're not getting chucked out, which means the community like us again, and that seems to be all pretty sort of goodness. We would like to get to Group A, and I'll talk about that in a little bit, but there's more work to be done for that. Most recent thing that happened, for those that are interested in these sort of things, Open vSwitch for Windows was just released. That was Cloud-Based Solutions did the work for that, but that's for those that are into these things, there's a virtual switch, and that allows interoperability, say, between Hyper-V and KVM in a heterogeneous environment. So that's kind of a nice little thing that's happened recently. We're trying really hard, of course, to persuade the Windows product team to pick up that code and actually just put it in Hyper-V permanently, but that gets us to another discussion. Is much as we've had the memos from the bosses that said you should use more open source, getting it from the memo to the action is kind of still a bit of a struggle. Just for those, this isn't meant to be some in-depth thing into OpenStack, but just to give you a feel for the sort of the way OpenStack really looks. If you ask me, who's a C guy, what is OpenStack, I'll tell you it's a Python library. Okay, but really there's two in the OpenStack world. There's two types of nodes within a cloud. One is a compute node, which is really, you've got Hyper-V or KVM or something running, and then you get stuff on top of it. Or you have a controller node, and you have a whole bunch of other. So you have a lot more Python libraries on the controller node, is how I would put it. But I'm sure other people would like to describe it more elaborately. But in essence, it's a bit like, it's not that different from a normal Windows environment. You've got a server there, you have LDAP and Kerberos, and then you have a bunch of APIs, and you have a database, and you have some message queuing. Nothing particularly exciting from a technology point of view. But that's just for those for context that we're going to talk about later on. So, Icehouse, another hurricane. The thing we needed to do there was we wanted to establish this continuous integration lab. And what that basically means is that whenever somebody submits a piece of code to the OpenStack code base, we will test that code with Hyper-V. So we kind of fire up a bunch of clouds, we run a whole series of tests, and the OpenStack community have a test suite, thing called Tempest, and we run these things, and we discover whether that code that was submitted is good or bad. Now, we don't have voting rights because we've not, a couple of things. We didn't join the foundation, which means politically we're kind of invisible, and we've not yet got to the point with our lab that they'll recognize as sufficient to give us. So that means we can't, if you have voting rights when you get a patch in, you can just go yay or nay and say, but right now as the situation stands, we can say, hey, this isn't very good, but it's up to them whether they listen or not. And then, the goals was maintain parity and stability with other current projects. So we want Hyper-V to be as good as something like KVM or VMware within the OpenStack cloud. And the last point we succeeded as well, doing this Open vSwitch to get interoperability between KVM and Windows and Hyper-V. Compute, so they have fancy names for each of things. Nova is the compute node within the cloud. As it says, Python stack. So we have you have to have Python there, a Python stack running on top of Windows, and then the rest of this stuff runs on top. Okay. And if you click on this link that I've given here, you can go and get MSIs and install OpenStack onto Windows pretty simply. So we're trying to make it as as typical a Windows experience as you would with installing any other software. There's a few other bits, there's, for instance, one in Horizon, which is yet another hurricane. We're going to test you how many hurricane names you've remembered by the end of this. No, they're not. I'm joking. I'm joking. Sorry, I'm joking there.
That's not the algorithm.
It is. It just starts with a letter and moves on. But they're usually female names, hurricanes, actually, aren't they?
Not yours.
Are they? Oh, don't tell me it's gone politically correct.
After Katrina, they stopped naming their
Repeat the question. Oh no, you don't really want me to talk about how we name hurricanes. Take that man away with the board. No, I'm not repeating that question. He's terrific. We have trouble causers at the back of the room. The sound man isn't meant to be my heckler, is he? Okay, let me come back to this. One of the other features we've recently got, we've actually used free RDP. Notice we're not using Microsoft RDP. There's free RDP, and really nice thing here is we get HTML5 support. So literally now you can connect to a host. If you've got a HTML5 browser, you can connect to either a Windows guest or a Linux guest using free RDP. And that actually, if you've looked at OpenStack, normally they use VNC as their access mechanism on Linux and things, but this gives us RDP on Linux and Windows. Although, interesting, no one's discussed it, but you could, of course, stand up VNC on Windows quite happily as well if you really wanted to. Right, continuous integration. We went live in mid-January. Built and maintained, it says, by a small team of engineers. I'm just trying to work. We get one missing, but all the others are in the room at the moment. I could embarrass you by making you stand up and do a twirl. Huh? Confession, there's one. Without getting too much into the kind of exact detail, one of the things we learned, and I'll talk about this a little bit more, I don't know if anyone's ever been tempted to try and build their own private cloud on existing hardware, but I'll say more later, but you probably don't want to do it on existing hardware. That's kind of painful. There's a little bit more about Open vSwitch here. I don't want to labor too much. Open vSwitch is completely independent of OpenStack. If you want to run Open vSwitch, for some reason you want KVM and Hyper-V interoperability, you can just install Open vSwitch onto Hyper-V, and that, as they say, Bob's your uncle. Well, they do where I come from, but that's give you a little insight. Sorry, for Steve.
On the previous slide,
why would you want interoperability?
No, I mean, interoperability is good in some ways, right? I mean, it's nice to be able to back up files to the same server and that sort of thing. Right?
Well, this is between guests inside two different hypervisors.
So I can think of two things I'd want to do. One is, mount each other's something, drives, or I don't know, USB, spare RAM or something. I don't know, but like, what would it mean that they're compatible?
Well, I mean, I think here's the kind of simple. If you're building a cloud, and the cloud itself considers the hypervisor to be a commodity. Oh, sorry, I got to repeat the question. What does it mean to be compatible in a cloud? Okay, with your hypervisors. In this case, with Open vSwitch. If you're building a cloud and you consider your hypervisor to be a commodity, you might have one. Let's just say you're in a really heterogeneous position where you consider that if you want to run a Linux workload, you would run it on a Linux hypervisor. If you want to run a Windows one, you would run it on a Windows hypervisor. Well, this now allows you the network connectivity between the two on a virtual LAN, which you couldn't get before. So. Anyone else want to shout why you might want Open vSwitch? Any other? No salesman for Open vSwitch? No. Okay. Does that make sense? Why? I mean, that's really the key to why you would want it.
I mean, you'd expect networking to work, but maybe what you mean is like the virtual networking between guests without having to go on the wire work.
Yes. Yes, that's correct. Yeah. Yeah, it's one of these little glitches you would expect to work, but doesn't necessarily work. And now we've kind of made it work, as it were. This was just to give you some idea. Now, just full disclosure, most of the development work that's done on behalf of Microsoft is done under the name of Cloud-Based Solutions. It's a company that we're paying to do the work. we don't pay to do, for, just to be clear as well, we don't pay for all their work, but we pay for a stack of the work that they do. So this just gives you some idea about the sort of level of contribution that has been getting made. But, you know, people often say, oh, Microsoft's not involved in OpenStack. Well, it's not quite true. We're just playing this, well, I was going to, Hashir, they described it as a proxy. I describe it as the half-pregnant scenario. We're definitely half in OpenStack, and we're definitely half out of OpenStack. And we can't really make up our minds. But Hashir's right in the sense that we're using cloud-based as a proxy right now. That's what everyone keeps saying to me. But you may be right, the market might change. But here we go. We're the lab in Cambridge spinning up something like 600 VMs a day. About 60% of the servers are in use at any time. And as I said,
maybe clarify a little bit here.
hold on, use the mic. I'm on your job for you now.
So just to give you a little perspective, when Neil is saying 600 VMs per day, it's essentially we're dynamically spinning up 600 clouds or instances of DevStack, what is called DevStack, in order to run the tests that are being requested of us by the upstream, to verify the upstream patches for us. So every instance of this is basically, you know, spinning up a cloud from scratch, setting up the VMs, and running a test against our Hyper-V instances, for example. Just wanted to clarify that. Thank you.
Testing the networking of the fixes, that's what it is?
It's you know, if
testing the patches to Hyper-V.
So-
They're either new code submissions or fixes. They're not.
so it,
For the OpenStack specifically, not just general fixes.
yeah. So if you look at OpenStack, it's essentially an API backplane, right? So we're just putting our Hyper-V in there as a compute node, which is called Nova. Similarly, we have the network driver, which is the Neutron. And what is happening is VMware might submit a fix saying, hey, this is for the Nova patch. So in order to scale to the requirements of this community, the upstream says, okay, all of you will now test what VMware has submitted to make sure that it hasn't broken, for example, Xen or KVM or Hyper-V. So we report that. And so given the size of the project and the momentum it has, it is not uncommon for us to be even now exceeding 600 test requests. And each one of these tests is more than 2,000 individual, what are called Tempest tests. So those are the unit tests. And it runs into sometimes millions, more than millions a week. Thanks.
So other things, and this is why it's just worth talking a little bit, because there's probably people in this room that might be tempted to do some things like this. Because we built this lab based on these repurposed servers, it turns out that things like differences in BIOSes, and of course older machines, you get failing components and things, but the difference in BIOSes turned out to be a pretty big pain. You know, if you want to build a cloud, there's this discussion about pet and cattle, which is probably a good time to touch on this subject. You know, if you're building a cloud, you want your servers to be like cattle. You know, and what we mean here is, you know, if you think of servers today, they're essentially all pets. You know, we cherish them all, we give them a name, and if they die, you know, we have a funeral, and we're all very careful about them. But really, if you're building a cloud, you want to treat them like cattle. If one of them dies, the only thing you really want to do is fire up the barbecue while you're firing up a new one. You know, and typically we don't eat our pets, so you know that is a model that makes a difference. And the kind of important thing there is you actually want your servers all to be as identical as possible. You really, unfortunately, the kind of features that server vendors give us in trying to differentiate their products in the market turn out to be the enemy of the cloud. We really want servers to be as generic and as similar as possible. And that gives you another interesting backstory to this is it's totally possible to take a whole bunch of your servers and repurpose them in the way that we did to build an OpenStack cloud. That turns out to be pretty painful, though. You know, you're much better to start, go out and buy yourself a bunch of new servers that are all identical. You'll suffer a lot less pain doing that than what we did. So, but you can see the temptation is, I've got a whole bunch of servers lying around in a data center somewhere. Why don't I make use of them and start a private cloud, you know, if nothing else, to kick the tires with. But that, and I'll get to yak shaving in a minute. You end up with doing a lot of yak shaving. You did a lot of yak shaving this year, has you? I know. Yeah, there's just a bit. So because of the whole history of the old ones, eventually I got a new manager, which meant when he wasn't looking, I said, hey, give me $500,000. I need to buy a couple of servers. And he said, yeah, sure. And he did a line item move. And so now we're building a new lab. It's good to get them new when they haven't settled in. You get much better decisions out of them at that point. He's not here, is he? Oh, damn, we're videoing as well. Crap. I keep doing that. Actually, I didn't know these videos ended up live on the internet. Well, a few years back, I did one of these talks. And the next thing I know, I get an IM from my brother saying, hey, I just saw you on Channel 9. And you were talking about porn industry in the Department of Justice. And I go, crap, did I do that? Oh, no. That was me talking about the Department of Justice insisting that Microsoft document protocols to help the porn industry. It was an accurate statement, but hey.
You just stay for the game.
I'm not picking on the Department of Justice. I'm just stating the facts.
Probably he's going to end up in YouTube too.
Hey, there's a challenge. Can we get on YouTube?
Tomorrow's viral list.
So, lessons from Cambridge. There we go. Don't build on cloud on hardware. Automate, automate, automate. You have to automate everything. Steve, you might want a microphone.
The lesson wasn't about the Microsoft Blooper reel. No, the thing I was wondering about was very obvious.
Oh, it might not be on. Is it on?
So the
Most important thing I was thinking about in reference to this, though, is, okay, this is good. You're testing, and you're testing Nova, you're testing compute, presumably Hyper-V. But what's not clear after you automate, is what actually you're testing. I mean, sure, you're testing Nova, but it's like...
Well, we're testing Tempest, which is the OpenStack test suite, is the answer, actually.
Yeah, but that even doesn't... So the community is doing something. They're testing some set of components. Tests are meant to find bugs and regressions. So you're changing components.
Well, we're not, they are.
Well...
Yeah, the community is.
Yeah, the community is changing components. Some of these components relate to things that Microsoft's interested in. So you could imagine, for example, Hyper-V as a guest. Sorry, Hyper-V being managed. You could imagine, Windows servers at one end of the. You can imagine interoperability things you're trying to test with Hyper-V and KVM, various other things. But understanding the test goals and how those test cases that you're running apply to what you're trying to test. Where the Microsoft component is, or here, maybe there's a Samba here, or a Windows storage server here, or maybe there's a Hyper-V something here, or maybe trying to understand the goals here would be kind of helpful, because clearly OpenStack is going to be enormous.
Yeah.
And it's sort of silly to run the whole test suite.
Maybe I can take a...
So go on, and then I'll butt in afterwards as well. Go on. Oh, I was going to say, I think there's multiple goals here. I mean, one of our goals, we have the uber goal of keeping Hyper-V as a recognized hypervisor as part of OpenStack. And that means whatever the community determines is a set of tests that need to be run, we will run these tests. But beyond that, we see the CI infrastructure as a mechanism. I mean, at one level, if you ignore OpenStack for a moment, what it allows you to do is detect that some set of bits have changed, run a series of tests against these changed bits, run a series of regression tests typically against these changed bits, and come out with a yay or nay. Well, we plan to, if you like, reuse this technology, that approach for a bunch of things. For instance, we talked to you about Cinder and Swift. We absolutely plan to have some tests in there for that. We also, like when Michael Kelly talked this morning about the Linux integration services, we also plan to do that. What we want to be able to do is take early changes to Linux distros fire them up and change them with early bits from Hyper-V so as that, we get to regressions much quicker than we currently do. And
then the related thing is, as a result of this test, Mr. Customer, you can feel more comfortable about plugging something in this block diagram. This block diagram, you've got Windows hosts, you've got Windows guests, you've got Linux hosts, you've got Linux guests, you've got Windows target storage servers, you've got Linux target storage servers. You're changing pieces of this, you're plugging in components. As a customer now, Fedora 19 can go here and we're happy. Showing what that looks like you can feel more comfortable, Mr. Customer, plugging in your Fedora 19 or 20 or whatever it is, or your RHEL 7 or here in this picture, because we do this testing in an automated fashion. So that's the context I was sort of missing from this.
Yeah, no, so, I think that will come. I think right now we're doing this, and we're doing this, I say, our primary motive is this, keep Hyper-V as a hypervisor as part of OpenStack. I think you're right, though, there are other companies already selling testing as a service in essence, so basically companies can subscribe to them and they're interested in a specific set of parts that are plugged together in the context of OpenStack, and they will run whenever, they will rerun the tests along with maybe some proprietary tests as well. In other words, they would run the testing to match some customer's predetermined configuration. I think from our perspective, one of the things we've not done yet, and I think once we have our new lab and we kind of, maybe a year down the line, what we'll start to see us do is literally start to publish tables of what we have tested, what we do test, and try and, if you like, I think maybe this is what you're digging at, give some meaning to what did the tests give you at the end of the day.
Maybe I can add just a little bit. When you are, all these points were very valid, Neil, and I think you nailed it, that making the customer comfortable.
It's not on.
I did turn it on. Showing me. Hello. Okay. The other important thing about these, the CI lab is that they are essentially a reference architecture for the world to look at and understand how they can absorb Microsoft technology into their OpenStack plans. And that's how I look at it. That's how a lot of people look at it. And it's not just Microsoft that's looking at it. By coming into compliance with a community mandated set of hundreds of thousands of tests, you're saying that we are complying by what your community has said. But in addition to that, we are providing them with an infrastructure. So it's not just the tests running. For example, I just talked a little bit about cloud spinning up automatically, Hyper-V being brought up. Now we are going to be working on the Cinder side of things. So the DevOps side of the equation, we have the infrastructure code in Puppet, for example. And that is part and parcel of this. So this lab is actually saying to the customer, here's a, which is what we tell our customer, here's the Puppet repositories for our components in OpenStack. So it's a reference architecture. Once we have this thing set up in Redmond, we'll absolutely let the customer see how the various Microsoft SKUs are working on this OpenStack backplane. Thank you.
Just to add, we've already got free RDP in there. One of the things we plan to do is get our protocol test suites and add them in. That's not community mandated, but it's pretty clear we have that test technology. We're going to deploy it, and once we get to Cinder and Swift and things, we will do something pretty similar with SMB, frankly.
And I think that what's really exciting for me is if you can imagine provisioning a VM in an optimal way in an environment that is SMB3 friendly, and then deploying it in a way where we can be safe that, in fact, the VMs are running on a stable storage platform. Obviously, it's a very small subset if we're running over Cinder of what we have to support. The SMB3 protocol is 100 times bigger than that.
Yeah, but that's what we can actually be broader than just Cinder. We've got the test suites. For us to put our protocol test suites into that space and add them as test cases is actually really easy.
And I think that'll be really, really exciting. And then figuring out which guests work and which ones don't is going to be really exciting. But it seems like a lot of this stuff is sort of a lot of this right now is unrelated to that. But but in the long run, being able to sort of imagine in all this wonderful Python garbage, being able to configure, right? I mean, this
No,
is,
no, the provisioning, absolutely, man. The ability to, I mean, that gets back to the automate. What you really want, you want to be able to just say, VM over there, stand me up, this version of Linux, running this configuration, and run these tests. And what you get back is a set of results. And now you spend your time about chasing down what failed, what succeeded, rather than worrying about the whole effort of running the test. You know, I mean, in a sense, we want to obsolete the human intervention with test running. That bit needs to be automated. And
I mean,
so that we
from
all,
our side,
so-
sorry, I don't know what the heck's going on. But from our side, it's going to be fairly simple to slipstream other tests into the CI once we have this Redmond infrastructure up, where we can actually spin up all this infrastructure on demand. So I can foresee a time when, you know, Plugfest like this could be using that.
yeah.
Just spin up a test scenario and let's get test results.
Okay, let's press on because we're getting close to lunch. By the way, for those that had, I'm sure the others that are sitting there, if you haven't seen the definition of yak shaving, this was it. You know, it's all these pointless activities which are actually necessary to solve a problem, which solves a problem, which solves a problem, you know, recursively, forever, which actually allows you to solve the problem you started. Anyone in this room not done some yak shaving recently? I have a suspicion that the IT industry actually currently is yak shaving, actually. Have you ever asked whether the yak wants to be shaved?
No, not with the boss says.
So just come back a little bit more about OpenStack. You know, the principle of OpenStack was hypervisor ubiquity. You know, they really do see, you know, they really are. OpenStack very much is hypervisor neutral. But we would like to get Hyper-V to a Group A status, really because we want voting rights. We want to be able to reject code. That's the real truth. You know, the truth is as well is the stuff that gets submitted to OpenStack, I think is, without being too impolite about it, is of variable quality, I think is a fair statement. Yeah. They don't really have a lot of gating over who gets to submit what, you know, so there is a fair amount of garbage, I think, goes into the pipeline. And it'd be very nice to be able to reject that quickly as possible. Yeah, so a few little summary things. Continuous integration testing is challenging. Workloads are still unpredictable. Exactly what workloads you should run is a different question as well. As I said, quality of submissions, OpenStack, pretty variable. We don't have voting rights, so we would like to get to voting rights. We'd like to have voting rights, and we'd like to be on new hardware, and we're trying to run as fast as we can to get to that position. Here's a bit of a play. You know, there's a few things. If you plan to virtualize Windows, then Hyper-V is the obvious place to do it. Okay. Not to say you can't do it on other hypervisors, but you know, there's a lot of optimization clearly goes on inside Microsoft to make that one of the best places. And as we said, we've done a lot of work, particularly recently, Michael talked about this, to try and improve Linux. We're really keen to get the Linux performance up as well. So we really expect to be, in the pretty near future, really on parity for Linux performance. We also want to get free BSD in there. A lot of people want that for appliances, and we're keen to give them that. And I would just point out, you know, I keep saying this, and I even did this in the heart of a lot of open source places. No one has yet convinced me that reading code is better than reading a spec. I'm, you know, unremittingly old school. Give me a bloody spec and I'll trust you. Give me a bit of code and I don't, you know. Unless it's C code, of course. So just to sum up, you know, you can do an all Windows deployment of OpenStack. That's not all in the code base yet, but we're trying to working towards that. So if you really wanted to do all OpenStack and it was all Windows, you will get that. You know, it's kind of interesting. The whole OpenStack thing has a really disruptive effect inside Microsoft. You know, if you talk to a Microsoft salesman and say, hey, I want to buy a cloud, as one does, you know, they'll go, well, we have this Azure thing here, and they want to sell you some of that. And of course, we have various other things. We have System Center Virtual Machine Manager would be their next chosen option for you. If you want to build a private cloud on-premise, that's what a Microsoft salesman would like to sell you. Of course, if you turn up and say, I want to build an open source-based cloud, that immediately eliminates the other two as options. And so now, reluctantly, they'll start talking OpenStack to you. But our sales guys are very confused, so just a warning. It's kind of hard for them at the moment. I do feel for them. If you want to contribute to this, I would love to hear from you. You know, this really is an open source effort that we're doing here. This isn't some, we're kind of almost skunk works inside Microsoft at the moment, is the truth. But
Especially after all that yak shaping.
well, exactly. One more. Peter, you want give him a microphone. Hold on.
More than anything, this is an editorial comment. Am I on?
No.
This is more editorial comment than anything. The hardest thing in the world right now is finding workloads, doing valid, something that represents the protocol mix, that represents the read-write patterns, that represents the content of the data. We are doing our best to do this, but we ask for your help. PCAP traces, we will anonymize. We don't need to steal anybody's data. Later this year, you'll be able to work with us. We are working on an ingest device.
You should name your company as well while you're at it. Get it on the video.
Oh, I'm sorry, of course.
Editorial comment.
It's a little company called Load Dynamics. We offer a testing appliance and software to go with it. We're willing to share. We realize that ultimately these workloads have to be shareable, used by others, so we're willing to do that. But we are desperate. You go to an enterprise, you want to put what on our system and take what from it, and they laugh usually. But without this, we'll never get there. So any help you can give us would be greatly appreciated. Thanks.
Okay, thank you. I have nothing more to say. I'll stop keeping you away from your lunch.